Hello and welcome to the Robot Podcast. I'm Fran Scott, scientist, maker, and massive engineering fan. In each episode, we'll be finding out how robots are pushing the boundaries of possibility and supporting businesses to make a more sustainable world. From the way we farm our food to how we package it, from 3D printing ocean waste into furniture to transforming cars into pieces of art, robotic technology is transforming our industries to reach an innovative and planet-friendly future. Today on the Robot Podcast, we're talking all about food. From farm to fork, we are going to track the journey our food takes and, of course, look at how robotics and discrete automation are involved in these processes. Now, of course, I don't need to tell you how important food is, but what you might not have thought about is the supply chain that's involved in getting the food to where it's need to be and how devastating any disruption in that supply chain might be. And it's not working perfectly at the moment. The UN estimated that between 720 and 811 million people went hungry in 2020. So this is the modern world and things aren't working seamlessly. And even if you didn't go hungry, there are billions of people around the world year on year that can't afford to eat healthily and nutritiously. And then on top of that, add the effects of climate change, then this adds further strains to how we grow produce. So we need to look at how to get maximum efficiency and minimum waste in these supply chains. So today we are finding out how robotics can help these issues. So to kick things off, let's hear from a good friend of the show, Andrea Casoni, Managing Director of the Global Business Line General Industry for Robotics at ABB. And as I was chatting to Andrea, it came as no surprise to me that robots are at the heart of the production lines that make the agricultural machinery, so equipment like your tractors and your harvesters. But I wanted to know what prompted that move to robots. And so to answer that, Andrea explained the challenges the farming and agricultural industries are currently facing.
They face similar challenges, and the most important one, the fundamental one, is the lack of workforce. This happens both in the field, but also in the manufacturing sector in general, and the manufacturing of agricultural machinery is no exception. So the workforce in the field is getting older, less and less young people are joining the field. So this clearly creates a major gap. You need automation there as well to fix the problem. And automation needs to be efficient. Automation needs to be affordable. And in this case, of course, for automation, we're talking about agricultural machinery, which have very long life cycles. Are produced in high numbers, but not as high as other kind of vehicles, say automotive, which also limit a little bit some of the possibility, or used to limit a little bit some of the possibility in the manufacturing process. Less and less if you start to automate the process of manufacturing agricultural machinery.
I got you. So here we're talking about the actual production of the machines that are then used on the farms.
Exactly. I would say this is even before we start to look at the field, the manufacturing, for example, of a tractor.
So how is robotics and discrete automation transforming these industries then?
Let's separate, right? In terms of jobs on the farm, there are all kinds of development machinery as drone or autonomous tractors, robotic harvester, automatic watering, and all kinds of other type of machinery using lots of artificial intelligence. But I think that's something that will be taken later in the episode, right? When we talk about machinery manufacture, the use of robotics brings the same typical effect that it normally brings in any kind of manufacturing. Robots are already used in a number of processes, such as cutting, bending, casting, welding, painting, surface treatment, and they typically bring the increased speed, increased efficiency, and increased safety that normally robotics does every time it enters a factory. And not only a factory, by the way.
I got you. So talking about these production lines, I suppose, where the agricultural machinery is actually produced. So in terms of this, you say the speed, the safety, the efficiency of this production line, and that being transformed by robots. Could you expand a little on that? Like, what does it look like? Do you have some facts and figures of it?
Speed is a classic, right? Robots increase the job per hour, so increase the amount of product that can be produced in a given time. Of course, it's possible to run 24 hours a day, increase the productivity of a line, which is a typical effect of using robots. But it actually also increases safety, as robots on production reduce operators' fatigue and often actually repetitive, heavy, or non-ergonomical tasks, operations that people don't want to do anymore, and they are perfectly suitable for robots. And finally, efficiency is the possibility to have a higher output with less input. In other words, reducing waste, reducing error, thanks to improved accuracy, and the reduction actually of even direct material when manufacturing a product, in this case, agricultural machines.
So it's these things that we've talked about time and time again on the Robot Podcast that robotics and automation can bring to production lines. But Andrea, when it comes to ABB Robotics, how specifically are they involved in the agricultural industry?
In the production of agricultural machinery, we have so many customers and so many cases and expanding, which I think it's really fascinating. So typically we support our customers in make their own tractors, harvesters, and other similar equipment or attachments. There are many examples. The first application that I can mention, and probably the first one that was really systematically used in the industry, was welding. And I can give you several examples, but let me take one of a family-owned business in Italy, which is actually one of the largest producers of harvesting attachment. They started with their first welding robot in 1997, and since then continue to use robotics. And now they have tens of robots, not only in welding, but also in assembly, mounting, in various kind of quality control, machine tending. So from what was a very manual line, now they have a completely automated line with the possibility to manage variation on their customers' request without the need to completely change the production line, which is a huge advantage for them and actually for any manufacturer. Another good example is a big famous name, one of the world leader in the industry, John Deere. They use ABB robots for painting since many years, and there are cases. I can mention one, for example, in India, where our robots paint more than 20 variants of tractors, and this has helped a lot because this operation was very difficult to be done by manual painters, very difficult from an ergonomical point of view, difficult points to be reached, which are not a big deal for robots, fortunately. And also typically with automation and robotics, you reduce overspray. So you reduce the wasted paint, the paint that doesn't go into the object.
With agricultural machinery, there's not going to be that high churn out of it, is there? Because they're very specific machines that are needed by a few people. So getting robotics involved means that you can personalize these machines quite easily and make them very specific for that specific farmer that wants those certain tasks.
As robot becomes more flexible, more intelligent, as the line around becomes also more intelligent and flexible through sensoring, with the use of AGVs or AMR actually, so autonomous mobile robotics, you can manage smaller batches. And this is what is now changing this industry. You don't need to have a super rigid, huge line making all the same product to put automation and robotics nowadays. You don't need. You just need to apply the technology that are available for smaller batches.
And as we look to the future, how do you see the farming and agricultural machinery industries embracing robotics and discrete automation in the immediacy?
Well, we will continue to see more and more deployment of robots, of autonomous mobile robotics, of collaborative robots also in this industry. They are becoming more and more used for a number of reasons, essentially for ease of use and flexibility. But also we'll see an increasing utilization of artificial intelligence. both in the field, but also as it happens in the rest of the manufacturing sector on the shop floor.
Gosh, so it's an exciting time.
It is. And it's an important field, right? Our food depends on that industry.
Andrea Casoni there, putting forward the challenges being faced by the companies that make the agricultural machinery, and of course, the solutions that robots can help come up with. But of course, that's not where the benefits of robotics stop in this industry, because take the actual physical farming, for example. Now that is an exact science, with lots of different things all needing to come together at exactly the same time to produce the most and the best crops possible. But excitingly, there is of course a myriad of ways that robotics and automation can help farmers in making the most of their crop. Now, I spoke to Ben Scott Robinson, co-founder and CEO of the Small Robot Company, to find out how their technology is changing the way farmers can interact with their fields. And Ben started by explaining the environmental impact that farming in its current form has on our planet.
So farming at the moment is an industrial process. It is driven by the idea that you need to use less and less people and more machinery, and that the very fields themselves are essentially just an industrial medium into which seed is pushed and chemical is applied to be able to produce a crop at the end of the day. This means that the machinery that's being used is industrial machinery. It's massive, it's damaging to the environment in terms of compacting the soil, and it's driven by the idea that one field is essentially one data point. They assume that everything that happens within that field is the same. What we are doing is really trying to understand not how to look at a field as a single data point, but as an individual plant. And when you get down to understanding the individual plants in the field, you realize all that big machinery is, one, hugely wasteful, and two, in many cases, just completely doing the wrong thing.
Is it working? It's worked in the past. Why is it not working now? Like, what has changed? Or is it just because there's new technologies available to us that we can actually make it better?
So for cereal farming, and bearing in mind cereal farming covers the world's largest crops and billions and billions of hectares worldwide, the production of cereal crops has become essentially inherently unstable. So all the places where there was traditionally some predictable weather conditions and predictable ways that you can grow crops, all of those places are changing. Whether that's fires happening in Australia, whether that's freak weather conditions such as wind or floods or drought happening in the US, floods in the UK. I don't know if you remember a couple of years ago, but the UK lost 40% of its winter wheat production. And even in Canada, freak early snows before harvest means that that entire harvest is lost. The second thing, the cost structure based around producing food has radically changed. So the cost of producing fertilizer, for example, has increased. The availability of fertilizer, because of Russia's production no longer being accessible to the world, and a lot of places now locking down on these very intensive carbon emitting capabilities to be able to produce things like nitrogen, means that the capability of farmers to produce food at a profit is going, even though wheat prices have gone up by more than 50% in the last year or so.
It's almost in crisis, I would say. And these are big percentages happening now or in the very near future. But you're looking to change that, aren't you?
Yes, we are. The concept of what we're trying to achieve is based around this idea of per plant farming. The way that we look to achieve that is by using lightweight autonomous vehicles to be able to gather a near real-time view of every single plant in a field over the course of the season as it grows.
You're surveying the land.
Literally surveying the land at a millimeter level, and then be able to process that using very sophisticated AI models to then allow other robots to go back and precisely and timely treat those plants to make sure each plant reaches its maximum potential.
Oh my gosh, that's huge.
So what we've done is we've produced a nominal service of robots that we call Tom, Dick and Harry. And Tom is a monitoring robot who goes out into the field all day, every day, and surveys each part of the field approximately once every 2 weeks. And we then process that using an AI called Wilma, which then provides this map and this constantly refresh, updated map of what's happening in the field. That part we call per plant intelligence. And right now, per plant intelligence can be used by farmers on its own by simply converting that map into a file, which is then put into their existing spot sprayers, which they can then take out into the field and use to more precisely spray the chemicals they're currently using to be able to drive down the costs for them, but also drive down the environmental impact of what they're doing. But ultimately, what we want to do is to close the circle, which is where Dick and Harry come in. So Dick is a precision application robot. Dick cares for the crops. And that involves being able to spray, sometimes they are chemicals, sometimes they're biologicals, on each plant individually to be able to treat that plant. But it also allows us to be able to use new technologies to be able to do the treatment. So, for example, recently we did a project around slugs and being able to find individual slugs in the field and spray them with biological treatment, a nematode essentially, which causes the slug to die from irritable bowel syndrome, if we're honest. It also allows us to be able to control non-crop plants using things like electricity. And we're partnered with a company called RootWave, who have a system that allows us to electrocute individual plants in the field to kill them and take out their roots. It's a systemic system, which obviously has no damage on any other plant in the field and obviously no damage on the soil. And that allows us to move towards a system which is called regenerative farming. You are literally working from the soil up to build a healthy environment in the ground. And this isn't just about increasing the yield or reducing the inputs. When you have a soil that is healthy, it absorbs up to 10 times more water than a degraded soil, which means that it can stand things like floods. It also holds the water in the soil for longer, which means you can withstand things like droughts. It also means that you can grow bigger and better plants, which means you can increase yields. What we are doing is working through the process of quantifying that. And by doing that, it means we have a system which is completely in tune with nature. It is far more capable of surviving. It is sustainable in the true sense of the word. And obviously has got a much greater chance of creating a sophisticated and rich biome and allowing the biodiversity that should happen in fields, rather than these sort of single crop monoculture dead zones, which is what most fields are.
That conversation with Ben, I just found incredible, because the insight that he gave into this novel and innovative approach of how to interact with the fields just blew me away. And it got me thinking about, is there other aspects of the industry where a really innovative way of thinking could really progress things in a way that we hadn't thought possible? And so that leads me nicely on to what happens after the farm, because, of course, after that, we need to make sure that the food is stored properly so it stays fresh and avoids waste as it's transported to where it's needed. So let's say the supermarket. And of course, that all comes down to the way it's packaged. And often the solution to this packaging, for want of a better word, is to use plastic. But we all know that plastic waste is having a huge negative impact on our planet. So a company that has an innovative way of thinking about this packaging is Zoom. Now, Zoom are a company that have created some of the most sustainable food packaging on the planet, in an absolutely incredible way, because they are making compostable molded fiber packaging from none other than agricultural waste. Of course, with the help of robotics and automation. And I was lucky enough to speak with Alex Garden, the founder of Zoom, to discuss all of this. But first, he explained how Zoom are so much more than just a food packaging company.
All right, so Zoom is a sustainability solutions company. We're operating a system now globally that sequesters carbon into not hydrocarbons. Now that is a huge agenda, and so it's a bit complicated how we do it. So let me explain the way our business works. So we operate a marketplace on two sides. And on the one side, we provide services to the largest brands in the world. So food companies and retailers, etc. So for those companies, we do everything necessary for them to start with something they use today that's plastic or EPS foam, and to end up with something which is made from a sustainable input with a low carbon footprint manufacturing process and a sustainable end of life story. So that typically means it's made from agricultural waste with very efficient factories built in countries with a short supply chain, and then home compostable end of life. Doing that and providing those products to brands at prices they can afford, that's already a huge complexity. It involves chemistry, material science, supply chain, testing, certification, quality, labs, standards, factory trials. It's an enormous amount of work. And that's great. But the problem with that side of the business is that when we're successful, and we are now in 26 countries around the world, the leadership of those brands turn to us and say, fantastic, now we need 1 billion a year of those to start, and we can't take any supply chain risk. And that leads me to the other side of our business, where we design, manufacture, and sell the most advanced fiber thermoforming equipment and whole factory level solutions. And these are giant $100 million plus factories that convert locally available agricultural waste through a complex manufacturing process that produces products that perform as well as plastic at prices that brands can afford. And these are in huge categories like trays that you see protein shipped in, cups for beverages and food, coffee lids, scoops. We make scoops for that replace injection molded plastic scoops, and frankly, hundreds of other things. And collectively, we're replacing billions of pieces of plastic a year, and that's a growing number. And we're doing it for some of the biggest brands in the world. It's really exciting.
My chin is on the floor as you've been saying that, because that is a huge scope. It just seems to make perfect sense when you're saying it. But obviously there's a reason this hasn't done before, and I assume this hasn't been easy for you to do. What sort of challenges have you come up against along the way?
Well, look, first, to pay respect to the people who've come before us. I mean, fiber thermoforming has been around for a long time. The real innovation for us was making the process of manufacturing these products significantly faster, operating at much larger scale, helping contribute to and working with some of the largest companies in the world, chemistry companies in the world, helping contribute to huge advances in the performance of molded fiber that make it more like plastic. And then coming up with an economic model which makes it possible to deploy large amounts of factory apparatus quickly, right? Because single-use plastics are a $320 billion annual business. And if you can believe this, we've produced more plastic, humans have, in the last 10 years than we did in the last 100 years. It's important for us to get grounded in the scope. We're talking about, hundreds of billions of pieces a year of plastic that are being produced. And the sad fact is that less than 6% of that plastic actually finds its way into a managed waste stream. So the rest of it is totally unmanaged. So the challenge of replacing it and not just making a small impact, right? Molded fiber historically has been about 5 to 12 billion of the total picture, not just a small impact, but really going after the whole single-use plastic picture and trying to replace it in our lifetime. That requires massive innovation. And that's what we do. So I want to make sure that people don't mistakenly think that we claim to have invented the technology. That's not true. But what we did is we created justification to bring it massive commercial scale and make it much faster and much higher performance.
And is this where robots come into it? Yes?
Yeah, well, robots and other forms of automation. So our factories contain, on average, they started at about 48 of our processing machines. Each one of those machines can process the theoretical maximum of 2 tons of material per day. So in a 48 machine factory, it's about 100 tons a day of processing. And to put things into perspective, a factory of that size, depending on what it's making, produces between 1 billion and 4 billion pieces a year of packaging, which, if you want to think about that differently, that's between 1 billion and 4 billion pieces of not plastic. Or another way of looking at that is 100 tons a day of not plastic, which sounds like a really big number until you consider how much we produce as humans and how much work we have to do to replace that.
And because robotics is at the heart of this production, it's just completely scalable, right?
Yeah. We sell our products today in 26 countries around the world. Part of the key to creating a way to scale this quickly was to move away from the historical paradigm, which was a bespoke factory, and to a paradigm that's actually been established in the semiconductor industry, which is what they call fab. It's a copy exact factory within the four walls. So our factories are effectively fabs, right? And whether you're building one in Guatemala or South Korea or Serbia, it looks basically the same way. This means that the amount of bespoke planning work that we would have to do normally when we were to put a big industrial apparatus like this in the ground is dramatically reduced. And that helps us go faster. Yeah, it really wouldn't be possible to operate factories at this scale and with the types of yields and throughputs that we're discussing without a huge focus on robotics, other forms of automation, computer vision, material handling, and a massive volume of sensors. And it all works together in one gigantic robotic circus. But without that, it wouldn't be possible to do this.
And of course, a great window into being able to see the possibilities that can happen if you unleash the power of automation and robotics into this agricultural industry. And so, yes, we've looked at agricultural machinery and the changes that it's making to the farm. We've looked at packaging, but now we move on to the fork end. And for this, we need a change of scene. I am in central London with my producers Izzy Clark.
Hello.
And Jack Claremont.
Hello.
And we are about to treat ourselves and go for lunch at Din Tai Fung, which is a dumpling restaurant that uses robots to help serve the food and clear the plates. Now, we can't record in the restaurant, but we're gonna head in, have some lunch, and we'll catch you after. Right, we are back and suitably full, and we cross-questioned so many people about the robots in there, and it was interesting to see, wasn't it?
Yeah, so there were two robots in there. So one was for clearing away the plates, and one was to help everyone serve the food. The three of us are sat around this table, and every time someone brought us some food, we're like, we have a question about robots. Excuse me. I'll start with the one serving the food. It seemed really helpful for all the waiting staff just to have like a little robot come from the kitchen into the middle of the restaurant, and then they went out to all the different tables.
Absolutely. Like in my head, I had that they might have been doing a bit more and in terms of delivering it closer to your table. But the fact that they delivered to certain spots around the restaurant, I thought, oh, is that helpful? But the more the time went on, and in terms of our discussions with the waiting staff, it seemed obvious it just saves that journey all the way back to the kitchen and then back out, which if you repeat that over a shift, that's going to add up.
They were bringing a lot of plates of soup, which I think is quite key, because actually that's a hard thing to bring when you're a waiter. It's a smart thing to have that they were able to do that.
Yeah, and so it's quite interesting to see how they actually work. So when we asked one of our many questions to the people that work there, it seems that there's like 4 different spots that they're programmed to travel around to. That can go up to 6, but they were able to just be like, okay, we need to go to this section of the restaurant, that's point A, and then after that I'll go on to point B. Yeah, it's just really interesting.
What we didn't do that perhaps would have been quite a good test is sort of stand in the way of the robot.
Well, actually, I did have like a Mexican standoff with one as I was going to the toilet, and it did stop and waited for me to go past, and then it carried on with its journey.
Okay.
So it knew what it was doing.
Yeah.
What was interesting, I suppose, was as well how the people actually having the food just sort of took them for granted. There wasn't this big ceremony of the robot being part of the staff, I suppose. It was just accepted.
I've seen other examples of it, a restaurant where they use them and they actually pay them a wage as well, which goes to charity, which is a really cool example. And Fran, you were saying that over in like Japan and places that you've been, that they're really advanced. But I think to see them here today, it was, like you say, it was seamless. It wasn't anything that was too shocking, but it was a nice way to see how robots can be integrated quite easily into a restaurant.
Fran, do you reckon you want to see more robots in restaurants?
Always. Now, unfortunately, that is it for this week because we want to go back in and sample our dessert. But a massive thank you to Andrea Cassoni, Ben Scott Robinson and Alex Garden. Next week, it's all about reshoring, which is about looking at the benefits of bringing production lines closer to home. And we'll be investigating the impact that this can have on global sustainability. I'm Fran Scott, and the Robot Podcast is a Fresh Air production for ABB. If you want to find out more about robotics at ABB, there's a link in the show notes. And remember to follow or subscribe now for free wherever you get your podcasts so you never miss an episode.
Part of the ABB Decoded series.